Let's start off by describing how it would work for recognizing objects in images. And let's suppose all we wanted to do was say whether or not there was a bird in the image. And let's suppose the bird's going to be roughly in the middle of the image and the main object of attention. And you have to say, is this a bird or isn't it? So you can think of an image. Let's suppose it's 100 pixels by 100 pixels. That's 10,000 pixels. Each pixel is 3 colors, RGB. So that's 30,000 numbers. And in computational terms, recognizing a bird in an image consists of taking 30,000 numbers and outputting one number that says yes or no, it's a bird. And you could try and write a standard computer program to do that. And people tried for many, many years, and they could never get it to work very well. Like for 50 years, they were trying to do that. Or you could make a multi-layer neural net. And I'll start off by telling you how you would wire up a neural net by hand. So what you do is you have the pixels, and that would be the bottom level. And then you'd have a layer of feature detectors. And a typical feature detector might have big positive connection strengths coming from a vertical row of pixels and big negative connection strengths coming from a neighboring vertical row of pixels and no connection strengths anywhere else. So if both rows of pixels are bright, it'll get big positive input from here, but also big negative input from there, so it won't do anything. But if these ones are bright, giving it big positive input, and these ones are not bright, so it doesn't get inhibited by these ones, it'll get all excited. It'll say, hey, I found the thing I like, which is bright pixels here and dark pixels here. And that's an edge detector. I just told you how to wire up by hand using positive and negative weights, something that would detect a little vertical edge. So now imagine you have a gazillion of those guys detecting different edges in different locations in the image, in different orientations, and at different scales. That would be your first layer of feature detectors. Now, if I was wiring it by hand, my second layer of feature detectors, I would maybe have a detector that takes two edges that join at a fine angle like this. So it's looking for this edge and this edge. And if they're both active at once, it would say, hey, maybe there's a beak here. It could be all sorts of other things, but it might just be a beak. So you have a feature that's sort of beak-like. You might also, in that layer, have a feature that detects a whole bunch of edges that form a circle. And so you'd have circle detectors and potential beak detectors, as well as lots of other detectors in that layer. But they're detecting slightly more complicated things. And then in the layer above that, you might have something that detects a potential beak in the right spatial relationship to a potential circle, a potential eye, so that it could be the head of a bird. So that would be like your third layer. And maybe if in your third layer you also got something that detected the foot of a bird and the wing of a bird, then maybe in the next layer you could have a bird detector. That if several of those things got active, like, okay, here's a head and there's a wing and there's a foot, it probably is a bird. Okay, so I told you how to wire all those things up by hand, but you'd never be able to do a very good job of it. So instead of wiring it all up by hand, we could imagine trying to learn it all. So I've told you the kind of thing we want to learn, but now I'll tell you how we learn it. And the way we learn it sounds bizarre at first. Instead of wiring in all the connection strengths so you get the detectors you want, you start with random connection strengths, just random numbers on all the connections. And so you put in an image of a bird, and you go forward through these layers of feature detectors, and it just behaves completely randomly. And the bird detector at the output will say 0.5, it's a bird. It's going to say 1 when it's sure it's a bird, and 0 when it's sure it's not a bird. To me, we're going to say about 0.5. And now you can ask the following question. How can I change all those connection strengths in the network? So instead of saying 0.5, it's a bird, let's suppose it is a bird, it says 0.51, it's a bird. So the question you want to ask is, how should I change a particular connection strength so as to make it more likely that it's a bird? And you can figure that out by taking the difference between what you got and what you wanted. So you wanted 1, and you actually got 0.5. You take that difference, and you send that difference backwards through the network, and then you use some calculus, which I won't explain, and you're able to compute for every single connection in the network how much you'd like to make it bigger or smaller in order to make it more likely to say bird. and you adjust all the connection strengths very slightly in the direction that are making it more likely to say bird. Then you show it something that isn't a bird, and now you're going to adjust connection strength so it's less likely to say that that was a bird. And you just keep going like that with lots of birds and non-birds, and eventually you'll discover that it's discovered all these feature detectors. It'll have discovered beak-like things and eye-like things and things that detect feet and wings and all that stuff. And if you train it on lots of different objects, like 1,000 different categories of object, it'll discover intermediate feature detectors that are very good for recognizing all sorts of things. So the magic is that there's this relatively simple algorithm called backpropagation that takes the error in the output and sends that error backwards through the network and computes for all the connections how you should change them to improve the behavior, and then you change them all a tiny bit, and you just keep going with another example. And surprisingly, that actually works. For many years, people thought that would just get jammed up. It would get stuck somewhere. But no, it doesn't. It actually works very well.